Hello students, good morning. Students, today we are going to discuss the second part of fifth chapter, that is acids, bases and salts. In our previous video, that is the first part of this chapter, we have studied about acids and bases. In acids and bases, we have studied about their classification, their properties and their applications. In this video, we will discuss about these topics, and the topics are indicators. Then we will study about their classification as natural and synthetic indicators. Then we will study about pH scale and universal indicators, then neutralization reaction, then salts and classification of salts, and at last we will study about neutralization reaction in everyday life. So students, let's start with indicators. So before starting indicators, I just want to remind you about acids and bases. We have studied that acids are sour in taste, bases are bitter in taste. It means if we are having any acid, when we will taste them, then it will feel sour in taste. Then bases will be bitter in taste. Then when we have studied about acids, then we have studied that acids are of two types, that is organic acids and mineral acids. So we have studied that organic acids are very mild, they are very weak. That's why organic acids are present in edible things that we eat, as lemon, curd, milk, and so many fruits are there in which organic acids are present. But we have studied about mineral acids also, and we have studied that mineral acids are very strong acids and they are very corrosive in nature. Then in bases, we have studied that bases are very bitter in taste. So obviously bitter taste is not good for us, but then also that bitter is okay, but that bases are also corrosive in nature, and most of the bases, they are corrosive in nature. So suppose someone has given us two solutions and we have to find out that which one is acid and which one is base. So only one thing we are knowing about acids and bases, that acids are sour in taste, bases are bitter in taste. Suppose we will taste them and we will find out which one is sour and which one is bitter. But in that case, we cannot forget that acids and bases are corrosive in nature. Corrosive means they can damage our skin. Means if that acids and bases get touched with our skin, with our finger, or suppose in case it touches our tongue, then what will happen? Our tongue or our skin will burn. So it means that we are not knowing whether the given material is acid or base, or suppose it is acid also, then also we are not knowing it is organic acid or it is mineral acid. So we cannot take that risk. Means every material that we are getting, just we have to identify, we have to find out which one is acid or base. We cannot taste them, because that tasting of these material will be very dangerous for us. So now there is a one problem, how we will find out that whether the given material is acid or base. So there is a solution of this problem. If we have to find out if the problem is the given material, we have to find out the given material is acid or base. So now there is a solution, and the solution is indicator. Now indicator, what is indicator? Indicator is simply, it is a chemical, it is a substance which is used whether to find out just given substance is acid or base. Means indicators are the substances which show quick or sudden changes in their color when they will react with acids or bases. Means if we have to identify, if we have to find out whether the given solution is acid or base, that problem is can be solved just by using indicators. indicators are the chemical substances which give different colors with acids or bases. So these indicators can be used to identify the given acid or base. That's why indicators are also called as acid base indicators. Now, the commonly used indicators are litmus, turmeric, phenolphthalein, red cabbage, red onion, then China rose, methyl orange. So many types of indicators are present. These indicators are present in each laboratory also, and we can find out whether the given substance is acid or base when we will use our indicators. Means when we will put some indicator in acid, then it will produce some color, and when we will use that indicator with base, it will produce different color. So if we will know that which color will be produced when indicator will be added to acid or it will be added to base, then very easily we can find out the given material is acid or base. So now, types of indicator. Now indicators, all of us know that indicators are the chemical substances which is used to find out, which is used to identify the given material is acid or base. Now we will study about types of indicators. So here the type of indicators are there. Indicators are of two types: natural indicators and synthetic indicators. Natural indicators means the indicators that we get from nature. Nature means we get indicators from plants. So the indicators which we obtain from plants, that indicators are called natural indicators. Examples of natural indicators are litmus, red cabbage, China rose, turmeric, etc. Then second type of indicator is synthetic indicator. Synthetic indicator means the indicators which we get from chemicals, means the indicators which are prepared by using chemicals. Those indicators are called synthetic indicators, and these indicators are prepared in laboratories. So these indicators are called synthetic indicators, artificial indicators, or man-made indicators. So some examples of synthetic indicators are phenolphthalein, methyl orange, methyl red, thymol blue, etc. Now first we will study about litmus. So litmus is a natural dye or natural indicator. In first chapter I have told you about litmus, because litmus is a natural indicator, and in that chapter I have told you from where we get litmus. So litmus is a natural dye, it is a natural indicator that is extracted from lichens. So lichens we have studied in first chapter. In symbiotic plants we have studied that lichens are the association of an alga and a fungus. So there I have told you that lichens are used as two type of indicators. First of all, lichens give us litmus solution which is used as indicator, and second type I have told you that they are very good indicator of SO2, sulfur dioxide pollution. So litmus is a dye, it is a natural indicator or natural dye which is extracted from lichens. This litmus solution, when it is formed in solution form, it is very light purple, very light pink in color, we can say purple colored. But when this solution, the whole solution form which is purple in color, when this solution is added to any acidic solution, then that solution will become red. When that purple litmus solution is added to the basic solution, then it becomes blue. Okay, now these litmus solution means litmus dye or litmus indicator comes in the form of paper strip, and two color paper strips are there, that is blue and red litmus papers, and means now dye or indicator, litmus dye, litmus indicator, it is widely used in these two paper forms, blue litmus paper and red litmus paper. Now we have to see what is the color change in blue litmus and red litmus paper when they react with acids or bases. So first of all, for this thing we need some materials, and the materials are lemon juice. Lemon juice, why? Because lemon juice contains citric acid. Then we need beaker, water, glass rod, sodium hydroxide solution. Sodium hydroxide solution is a basic solution, it is a base. Then we need paper, litmus paper strips, and both red and blue. Then what we have to do, we have to take lemon juice in a beaker, and we have to add some water in it. Then we will stir it, means we will mix it properly by using clean glass rod. Then we will take red litmus paper and blue litmus paper. Then what we will do, first of all, we will dip blue litmus paper in the lemon juice solution. So when we will dip blue litmus paper in the lemon juice solution, then we will see that blue litmus paper will turn into red color. Okay. Then when we will dip that red litmus paper in the lemon juice solution, then that red litmus paper remains red in color. Okay, now we will take sodium hydroxide solution in a beaker, and then we will dip red litmus paper to NaOH, sodium hydroxide solution. Then we will dip that red litmus paper into sodium hydroxide solution. It will turn blue in color. Then again we will take blue litmus paper and we will dip in the sodium hydroxide solution. Then blue litmus paper will remain blue. So from this activity, we can conclude that red litmus paper, when it reacts with base, then it turns blue in color. And blue litmus paper, when it reacts with acid, it turns red in color. Okay. Then our next type of natural indicator is turmeric. Turmeric, all of you know turmeric, that is haldi powder. It is used in our kitchen. So turmeric is also a natural indicator, means a natural dye. This is very commonly used indicator, and very easily you can test that indicator at your home, because at your home all of you having lemon juice, lemon you all having. So in lemon you will get the citric acid and detergent, that is surf. So from that detergent or soap you can use, because in that soap or detergent bases are present. So very easily you can get that acid solution and basis solution at home. All of you having turmeric at your home, so very easily you can test the turmeric indicator and you can see the color change with the reaction with the acid and base. So this turmeric is a natural indicator. All of you knowing haldi. As such, haldi powder, as such turmeric powder you can use for testing as indicators. But in market it is available in the form of paper strip. So how it is made, just we have to take a blotting paper and we have to cover it, we have to coat it, or we have to put that paper strip, paper strip in the turmeric paste, and we have to dry it. So turmeric is basically a basic indicator, means when turmeric reacts with base, it changes into, means all of you know the color of turmeric is yellow. So when turmeric indicator reacts with basic solution, it turns red in color, and when it reacts with acidic solution, then it will remain yellow in color. Means turmeric will give red color with base and no color will with acid. That is why when we get any turmeric stain on our cloth and we will wash it, we will start cleaning it using detergent or surf, firstly it get turned into reddish brown in color, because our soap or detergent contain base and Turmeric is a natural indicator which gives reddish brown color when it reacts with base. And when we will add turmeric with lemon juice, as lemon juice is acidic, so there will be no color change. Turmeric is yellow and it remains yellow. Then our next type of indicator is China rose. China rose also, all of you know, good health or hibiscus. So it is also a natural indicator. So how this China rose indicator is prepared? This indicator also very easily you can prepare at home. Just you have to take some China rose petals, then keep this China rose petal in any container which is having water, and just boil it for some time. After boiling China rose petals in water, the solution will become pink in color. Now at your home you are having, again you are having lemon juice. Lemon juice is acidic, and detergent, it is basic in solution. Now both type of acidic and basic solution you are having, and you are having your China rose indicator also. So you can find out which color the China rose indicator will give with acid and which color it will give with base. So when China rose indicator reacts with acidic solution, then it changes into dark pink color. Means firstly China rose indicator in solution form, it is very light pink in color, but when it will react with acidic solution, it will become dark pink, means magenta color, and when it react with basic solution, then it will give green color. Now our next type of natural indicator is red cabbage. Red cabbage also, all of you are knowing red cabbage. So red cabbage is also a natural indicator. We can make this indicator by taking few leaves of red cabbage. When we will mix it, we will keep that red cabbage leaves in water, and again we have to boil it. Same procedure as we have done in the case of China rose. So when we will keep this petals in water and we will boil it for some time, again the solution will become very light pink in color. So again you can test it with acidic and basic solution using lemon juice and detergent solution. So when it reacts with the acidic solution, it will give bright red color, and when it reacts with basic solution, then it changes into dark purple in color. Now, next type of indicator is synthetic indicator. In synthetic indicator, all of us know that synthetic indicators are the indicators that are prepared in laboratories using chemicals. So two examples are there. First one is phenolphthalein and second one is methyl orange. So students, phenolphthalein is a synthetic indicator, or we can say man-made indicator, and it is generally basic indicator. Means it is first of all, what is the use of indicator of phenolphthalein indicator, why we use it? So phenolphthalein indicator you will use when you grow up and you will go in higher classes. Then you will do an experiment, that is titration. So this phenolphthalein indicator is basically used in the titration reactions to know the end point, means where the reaction is completed. To know that point, phenolphthalein indicator is used. So phenolphthalein indicator as such is a colorless, just like water, means it is just in colorless solution. When it reacts with basic solution, then it gives pink color, very bright pink color. You can see in the image, it will give very dark pink color in basic solution, and it remains colorless in acidic solution. Then next one is methyl orange. So methyl orange is also a synthetic indicator, and it will give a yellow color in basic solution and red color in acidic solution. Now next is our pH scale and universal indicator. So first we will see what is pH scale. Actually first we will see what is universal indicator. A universal indicator is a mixture of many indicators that we will study later on. First, we'll see what is pH scale. So, pH scale is a scale which is used to measure the relative strengths of acidic and basic solution. Means this indicator, universal indicator, gives color change with both acidic and basic solutions. So, if we want to know the strength means how strong any acid or base is. So when we have to know the relative strength of acidic and basic solution, then we use pH scale. So pH scale goes from 1 to 14. This is pH scale, you can see. So the range of pH scale is 1 to 14. On a scale, 0 is also mentioned. So we can say it is from 0 to 14. A very strong acid will have pH of 1. Okay, see, the pH scale at 7th point is it is neutral, and from 0 to 6 it is acidic, and from 8 to 14 it is alkaline. So very strong acid will have a pH of 1. It means many hydrogen ions are present in solution. In previous video, when we were studying about acids, then I have told you that acids in their solution form, in their aqueous solution form, means in the solution of water, they releases H plus ion, and in bases we have studied that bases gives OH minus ion. So acids gives H plus, means positively charged hydrogen ion, and bases gives negatively charged hydroxide ion, that is OH minus ion. So strong acid will have pH of 1, means many hydrogen plus ions are present in the solution. It means acid is very strong. It means we can say that if pH is 1, it means acid is very strong. Then if pH scale shows the scale range of 13 to 14, it means very less number of hydrogen ions are present, means a very less number of hydrogen ion are present in solution, and in that case the solution will be strong alkali. So in pH scale we can see at point 1. First of all, see at point 0 it is very red in color. At point 1, suppose pH scale is showing 1, it means the solution is very strong acidic, lot of hydrogen ion are present in that solution. If it is uh, on 14, in between 13 to 14, and at we can say at 14, then it means very less number of hydrogen ion are present, and it means that solution is very strong alkaline, strong alkali, or we can say basic. And if pH scale shows the 7 number, it means it is neutral. So at that point it shows the green color. Now neutral solution will have pH of 7, strong acidic solution will have pH of 1, and strong alkali solution will have pH of 14. Then pH of any acid can be determined with the help of pH paper or. So now students, our next topic is universal indicator. Universal indicator is a mixture of many indicators or many dyes. Several dyes are present in that, and it gives different colors at different pH values of the entire pH scale. You can see the pH scale, it starts from 0 to 14. So entire pH scale at each and every point from 0, 1, 2, 3, and to the 14, at each pH point, at each range, universal indicators give color, different colors. So it is used to know the chemical nature of substance, means we can know whether the substance is acidic, basic, or neutral. One more thing is there, we use this in universal indicator to find the strength of the substance. Strength means how strong any acid or base is. So it indicates the chemical nature of the substance as well as the strength of the substance in term of pH. So example of universal indicators are first of pH scale. pH scale gives the pH range of each and everything at each pH point, each range. And next, universal indicator solution, which is generally made up of thymol, blue, methyl red. Means so many type of indicators are there: thymol blue, methyl red, bromothymol blue, phenolphthalein. Then water will be present there. So these solution make in universal indicator like this. So many other universal indicators are there. So universal indicators tells us the chemical nature, whether it is given substance is acidic or basic. Because what do other indicators do? They don't tell us the pH. They just give an idea the given substance is acidic or basic, but they do not tell us how strong acidic or how strong basic any substance is. But when we will use universal indicator, then we will come to know how strong acidic or how strong basic or neutral substance is there. So at pH paper, when we will see, we can see the examples representation of various substances are there, and their pH values are given. You can see battery acid. Battery acid means sulfuric acid, we have studied in last video. Battery acid, it is having pH point that is 0.5. Then gastric juices, gastric acids, that is produced in our stomach, it ranges from 1.5 to 2. Then you can see the pH range of pure water, which is dark green in color. You can see it is 7. Then our human saliva, it is 6.5 to 7.4. Then our blood also having the pH range of 7.34 to 7.45, means it is basic. And you can see the pH value of bleach, it is 12.5. It means that universal indicators, means pH scale is also like that. So they tell us how strong acidic. Now here we can say that battery acid, it is very strong. And we can say that bleach, it is very strong, basic. So pH scale or universal indicator tell us how what is the strength of any material, how strong acid or how strong base any material is. So pure water has a pH value of 7, and it is neutral solution. Then the solutions or the substances having pH value less than 7, then they will be acidic. If the pH value is 0 or 1, then it will be very strongly acidic. And if the solution having pH value more than 7, then they will be basic. And if pH value is 13 or 14 and between 13 14, then they will be highly basic. Now, neutralization reaction. Now we have studied about acids and bases. Now what happened when acids and bases react together? So when an acid and a base, they react together, they form two products, that is salt and water. Both salt and water, they both are chemically neutral, means they will not give any chemical reaction, means they will not give any reaction of acidic solution or any reaction of basic solution. It means that they are neutral. So reaction between an acid and a base, so we can say that when an acid and a base react together, they form salt and water, and this reaction is called neutralization reaction. So salt and water, these are the two products of neutralization reaction. Along with evolution of heat, means some amount of heat energy is also released in this neutralization reaction. So reaction between acid and base is called neutralization reaction, and in this reaction water and salt are produced. Now the salt and water, they will not bring any color change in any indicator, then they are called, then they will be neutral. That is why in this reaction acid and bases, they both are reacting together and they are forming neutral substances. That's why this reaction is called neutralization reaction, means they both are getting neutralized, means the properties of acid and properties of bases, they both will be neutralized and they will form neutral substances. That's why this reaction is called neutralization reaction. So one example we are having here, hydrochloric acid is reacting with sodium hydroxide. Hydrochloric acid means HCl and sodium hydroxide means NaOH. They both are reacting together and they are forming NaCl. NaCl means sodium hydrochloride, sodium chloride. This is a common salt. So HCl, hydrochloric acid, and NaOH, sodium hydroxide, they both are reacting together and they are forming sodium chloride, that is NaCl. It is a salt, and H2O, that is water. Now, salts. What are salts? So, all of us know, after neutralization reaction, the substance formed is salt. So, salts are the substances which are formed by reaction between, or neutralization reaction between acid and a base. So, when an acid and base, they both will react, they will form salt. The salt is neutral in nature, means it will not show any acidic or basic properties, and they will not bring any color change in the indicators. Now, how we will come to know that the solution, that the salt which is formed after neutralization reaction is neutral? So when one very simple activity we can do, we can take one test tube. Okay, suppose you are having litmus paper strips at your home, you are having with you, you are not having test tube, then also just take a small box, small container, then take some salt, common salt which we use at our home, that common salt, and take some amount of water and dissolve that salt in water and form salt solution. Then one by one take red litmus paper or blue litmus paper and dip in the salt solution. You will see blue will remain blue, red will remain red. There will be no any color change. No any color change in the litmus paper. It means that that solution is neither acidic nor basic. Means it is a neutral substance. If you are not having that litmus paper, then you can test it with by using red cabbage solution if you're having red cabbage at home. Otherwise you can test it with turmeric or china rose solution also. Now, salts, classification of salts. So salts can be classified in three groups, that is acidic salts, basic salts, and normal salts. So for normal salts, everything will be okay. It will not give any change in the color of any common indicator. Actually, this classification is based on the how strong any acid or how strong any base is, means what type of acids and bases are reacting together. On the basis of strength of acids and base, these three types of salts are there. The salts are classified in three types, that is acidic salts, basic salts, and normal salts. So first we will see acidic salts. Acidic salts, as from the name it is clear, acidic salts means salts which are having some properties of acids. But how? Here we are saying that acids and bases, they are neutralizing and they are forming salts. But this is the condition in that for both acids and bases, they are of equal strength. Means they are, if we are using weak acid, then we will use weak base. If we are using strong acid, then we will use strong base. In that case we will get the neutral salt. Otherwise, conditions are there. So suppose neutralization reaction is taking place between a strong acid and a weak base. Means acid is a strong and weak base is weak. So when chemical reaction takes place between a strong acid and a weak base, then the salt form, that salt will be acidic salt. Why? Because acid is strong and base is weak. So some amount of acid will be neutralized by base, but some acidic content of the salt, some acidic content will be there, and means full complete neutralization of acid will not take place. Some amount of acid will be there. So in that case, the salt which is formed in the reaction mixture, it will be acidic. So the salts which are formed by the reaction of strong acid and weak base, that type of salts are called acidic salts. So they will have dual nature, they will behave like salt as well as acid. The examples are sodium hydrogen sulfate, sodium hydrogen carbonate. Sodium hydrogen carbonate is also called as sodium bicarbonate. All of us know NaSCO3, that is baking soda, and then sodium hydrogen sulfide. Then basic salt, that we have studied in acidic salts, just opposite to them. Here there will be reaction between a weak acid and strong base. When base will be strong and acid will be weak, then some amount of base will be neutralized with acid and most of the acid will be left there, means there will be incomplete neutralization of base. So in that reaction mixture, some salt will form and that salt will be basic in nature, because in this case strong base and weak acids are reacting together. So incomplete neutralization will be there. The bases will not be completely neutralized. Some amount of bases will be left in the reaction medium, and the salt which is formed, it will be basic in nature. So again the salt will have dual nature. It will behave like salt as well as acid. So examples of basic salts are magnesium hydroxychloride and calcium hydroxychloride. Now normal salts. Salts are all okay. The bases or acids, they both are of equal strength, means weak base will react with weak acid and strong acid will react with strong base. So if this type of reaction will be there, then both acid and bases will be completely neutralized and they will form salt. That salt will be normal salt. So normal salt are the salts which are formed by the neutralization reaction, complete neutralization reaction between an acid and a base. So example of this is sodium chloride. So as we have studied here, sodium chloride, it is formed by the reaction between HCl and NaOH. So it is sodium chloride. Sodium chloride is the normal salt. Then HCl, strong acid, NaOH, strong base. They both are reacting and they are completely neutralizing in this reaction. They are forming NaCl, sodium chloride, which is a normal salt. And next one is sodium sulfate. So it is formed by the reaction between NaOH, sodium hydroxide, and H2SO4, sulfuric acid. So again sulfuric acid, strong acid, and NaOH is strong base. So the both are reacting, completely neutralizing, and they are forming normal salt, or we can say neutral salt. Now applications of some important salts, means what are their applications. So first of all we will see sodium chloride, common salt, NaCl. So all of us know we use this salt in our kitchen. This is the common salt which we use in our food. Now all of us know that it is used as a preservative in pickles also. Then it is used in curing meat and fish. They are used in industries for the manufacture of chlorine or hydrochloric acid or washing soda, sodium hydroxide, etc. Next type of salt is sodium carbonate. Sodium carbonate means Na2CO3, means it is commonly it is called as washing soda or soda ash. So obviously it is washing soda, means it is used in the laundry also, for washing clothes, and then it is used in the production of glass and detergent powder, means that the detergent powder that we use at our home, it also consists of sodium carbonate. Then sodium bicarbonate, NaHCO3, sodium bicarbonate or sodium hydrogen carbonate, its common name is baking soda. So obviously it is used as baking powder. It is also extensively used by us in our kitchen for baking purpose. Then it is also used in as a fire extinguisher. Then it is used in medicines to neutralize acidity. Then next one is magnesium sulfate. Magnesium sulfate means MgSO4, and it is commonly called as Epsom salt. So it is used as purgative. Purgative means luxative. Luxative means by which stools can pass easily. Okay, so in case of constipation, it is basically, it is comes in the form of medicines. MgSO4 is present there, so it is used as purgative. Purgative means laxative, by which stools can pass very easily. Then it is also used in textile industries. Next one is potassium nitrate, KNO3. It is also called as nitro. It is used in the production of gunpowder. Gunpowder means it is used as explosive powder. It is explosive powder. Gunpowder means explosive powder, which is used in guns. Then it is also used as fertilizers. It is used in the production of fireworks, gunpowders. Then it is also used in refrigerations, in medicines, and in glass industries. Then next, copper sulfate. Copper sulfate means CuSO4. Its common name is blue vitriol. So in next chapter we are going to study about copper sulfate also. It is blue in color. So it is used as fungicides. Fungicide means chemical that kill fungus. Insecticides also we have studied, the chemical which kills insects. So here fungicides means the chemicals, the chemical substances which is used to kill fungus. Then it is also used as medicines. Next one is very important, that is potash alum. Potash alum means common name is fitkiri, and it is double salt, K2SO4 into Al2SO4 ka whole thrice into 24H2O. This is potash alum fitkari, all of you knowing fitkari. So it is used in the purification of water. Then it is used to stop bleeding from minor cuts. You all have seen, if the gents at your home, they do shaving at home, then they use fitkiri there. Then it is used as mordant for tanning leather. Tanning leather means when the dyeing or coloring of leather is done, then it is used as a fixative agent which fix the color on leather. Then applications of neutralization in everyday life means how we use that neutralization reaction, how that neutralization reaction is used in our everyday life. So first of all, indigestion. All of you know that our stomach contains hydrochloric acid. It releases hydrochloric acid which help us to digest food. But due to the presence of too much acid in the stomach, when our stomach secretes too much acid, it leads to indigestion. Means when too much acid will be there, then this condition is called acidity, and in that condition digestion will be improper, then it is called indigestion. So it is very painful because the acid penetrates the lining of the stomach. So to get relief from indigestion, we take an antacid such as milk of magnesia. We have studied in previous video milk of magnesia, that is magnesium hydroxide, which is a base. So when too much acid will be present in our stomach, when we will take this basic solution, that is milk of magnesia, magnesium hydroxide, so it neutralizes the effect of excessive acid. Then sodium hydrogen carbonate means sodium bicarbonate, that is NaHCO3, or we can say baking soda is also used. It is also a strong base, and it can also give us relief from indigestion. Then next one is ant bite. So as we know, ant contain formic acid. In previous video, we have studied about this, that ant sting contain formic acid. So when an ant bite, it injects the acidic liquid, that is formic acid, into our skin, which causes swelling, burning sensation, that feeling of burning and pain in the skin. So neutralize the effect of that sting, moist baking soda, again baking soda, sodium hydrogen carbonate or sodium bicarbonate, or calamine lotion. Actually, calamine lotion contains zinc carbonate, which is basic in nature. So when ant is injecting formic acid means it is acid which is creating, which is causing pain in our skin. When we rub that baking soda or calamine lotion, which is basic in nature, on that sting, then the effect of that formic acid will be neutralized. Next one is soil treatment. So students, one more thing, if our soil is very acidic, too much acidic or too much basic, then the plants will not properly grow there. Means mostly the soil should be neutral, just in order to get the proper yield of the plant, proper yield of the crop. So how the soil become excessive acidic? Because excessive use of chemical fertilizers that the people do in the soil results in increased acidity of the soil, which is not at all suitable for proper plant growth. Plants cannot even grow well in the soil which is too basic also. So when soil is too acidic, it can be neutralized by treating with bases. Bases like quicklime. Quicklime means CaO, calcium oxide, or slaked lime. Slaked lime we have studied in that video. That is calcium hydroxide. So if soil is acidic, we are using the basic thing to neutralize it. If soil is too much basic, then soil is neutralized by using organic matter. Organic matter means the compost or manure, etc., which releases acid and which neutralizes the basic nature of the soil. Next one, which is the most important one, that is factory waste treatment. So the waste which is came out from the factories, which are excreted or expelled out from the factories, are highly acidic and can cause threat to the survival of the marine ecosystem. Means aquatic life, aquatic plants or small aquatic animals are there. The release of these acidic waste into the water bodies can kill fish and other organisms. So due to which the factory waste are properly neutralized by adding some basic substances. So these waste which are coming out from the factories, they're acidic, they should be neutralized by using basic substances. So these are the application of neutralization reaction that occur in our daily life. So this is all about our fifth chapter, that is acids, bases and salts. We have studied about acids, their properties, their classification, their application. We have studied about bases, their classification, properties, applications. Then we have studied about indicators, type of indicators, various type of indicators we have studied. Then we have studied about pH scale and universal indicators. Then we have studied about salt. So before starting salt, we have studied about neutralization reaction. Then we have studied about salt, their classification, then their applications of various salts, and at last we have studied about neutralization reaction in our daily life. So everything we have studied. So these are the some understanding based questions. You will get the answer in this part only if you will watch the video carefully. So first question is why are indicators so important in laboratories? So all of you know why indicators are important, because acids and bases are very dangerous, they may be dangerous. So you have to write these question answers in your copy. You can write these question answers even in your additional copy, not in fair copy. Then next question, from where do we get litmus? This is also very simple. Then which acid is present in carbonated beverages? How the process of neutralization help in the treatment of indigestion? What is the chemical name and formula of Epsom salt? What do you mean by acidic and basic salts? And how can we factory waste dangerous for aquatic life? So watch the video and read the chapter. If you will have any problem, then first read the chapter, then watch the video and write answers of these questions in your additional copy. Thank you, students.